This diagram shows the energy density as a function of wavelength, as predicted by classical physics. The Rayleigh-Jeans Law uses an idealized cavity with a small opening as a model for blackbody emission. The blackbody emission is perhaps better thought of as thermal emission, since ideal blackbodies do not exist, and of course most objects we consider, like our sun for instance, appear to be anything but black to us. The model using classical physics is based on the idea that modes of radiation are trapped inside the cavity. Some of the radiation escapes, and this is what we know of as thermal radiation. The problem with this model is that classical physics predicts the energy density ρ, seen on the left side of the graph on the figure, increases without bound as the wavelength is lowered. In other words, as the energy of the radiation increases. This theoretical prediction is clearly wrong. For example, the Wien displacement law predicts that the maximum of the thermal emission will be inversely related to temperature. The Rayleigh-Jeans law, as you can see, does not even predict a maximum. Again, the radiation simply increases without bound. The Wien displacement observation is not explained at all. When this discrepancy was first realized by physicists, they called it the ultraviolet catastrophe. As you can imagine, they were really puzzled that Maxwell's theory failed to explain something so basic. Remember, for example, that thermal physics is needed to explain why our Earth can have a temperature that's different from the sun. It has to radiate at one temperature and one wavelength, while the sun radiates at another temperature and another wavelength. The wavelength and the temperature are somehow related. This equation that you see here simply fails to explain that. The resolution of this physical problem is a simple assumption regarding the spacing inside the cavity. As we will see, the Rayleigh-Jeans law can be replaced with an accurate model simply by assuming that the energy of the radiation can be quantized.